This video is for our Module 14 review. So I'm just going to go through some of the questions in Ed. So these are pretty similar to the questions that you will see on our test tomorrow. So if you are struggling with any of these or have any questions, be sure to let me know before you take your test and we can set up a time to meet together. So I'm going to start and let's just review all of these vocabulary words and then I'll let you decide which one matches into each of these. So data is our information. So it might tell us how many hours people read, how long they worked for, how long the each of the shows were. It could say how many lawns they mowed each week, how long or how tall each flower grew each week. So it can tell us anything. So data is just when we're keeping track of that information. It could be over time or asking lots of people. The dot plots are when we take that data and we arrange it in order, least to greatest, and a dot or an X marks each piece of data. So every dot or X stands for one of the pieces of information that we collected. The frequency table and histogram work together. So the frequency table is when we take our data and we break it up into equal groups. And then we say how often or how frequent it happened. So you might have a group that says 1 to 5, and 1 to 5 happened 3 times. And then 6 to 10 happened 7 times. 11 to 15 happened 2 times. So you're breaking them into equal groups. So my groups each had 5, 5, 5. And then how many times did those happen? Then you can take your frequency table and turn it into a graph. So the histogram is the same data as the frequency table. So the bottom x-axis is those same groups, those intervals, and then you just draw a bar for how frequent it happened. If it happened 2 times, 3 times, 7 times. And those bars need to touch each other, and then they just show the frequency that they happened. So this is a table, just a list. The histogram is on an X and Y axis with bars that go up and down. And statistical questions are questions that have many answers from many people. Lots of answers, lots of people. So some examples might be if I asked the whole class, what's your shoe size? Because if I just asked you, what is your shoe size? You're going to have one answer. I wear a 7. That's your answer. Okay, it's data, but it's not a lot of data. So a statistical question would be asking every person, what is your shoe size? Keeping track of that, then using that data. I could ask, let's see, everybody in my family, what is your favorite color? Some people might have the same answer. Some people might have different answers. Lots of people, lots of answers. So I don't want to ask a question that just is a yes or no question. That's not a good statistical question. Or just asking one person a question, not a statistical question. Asking your classmates or the whole school or the whole community or everybody in your family a question that has different answers. So not just, did you like the show? That's fine, but we can do better than that, okay? Statistical questions also don't just do one thing. So on one of our homework questions, it said, how many tomato plants are in a pot? A pot. How many? Just one. One pot is not enough data. If I asked how many tomato plants does everybody in my neighborhood have, each person in my neighborhood, then that turns it into a statistical question. So we can take these non-statistical questions. How many tomato plants are in a pot? And I can change it and ask more people or look at more pots. So not just one pot, how many are in everybody's pots in my neighborhood or in their gardens? So go ahead and decide which is a graph that has bars that represent the frequencies with equal measures. So a question that has many different or variable answers. A set of information collected about people or things, often to draw conclusions about them, is referring to. A graph in which each piece of data is represented by a dot above a number line is. And a table that lists items together according to the number of times that the items occur. So there's all your vocabs. Let's go through and look at some of these questions here. So use this information to answer parts A, B, C, and D. The times in seconds that it takes barrel racers to complete their barrel runs at a rodeo are shown. So first it wants to know what attribute is being measured by the data. So remember, the attributes are just what, let's actually look here. Consider the units of times, right? What time is it being measured in? How many, like what was it looking at? So this is looking at the time or the seconds that each barrel racer completed their run. So the time the barrel racing event starts, and this is not what time it starts, the time the barrel racer starts their runs, right? These aren't times that things are starting. This is their entire event. The time it takes barrel racing event to complete, right? So it's not the whole event from start to finish. This is a barrel racer. Each of these are representing one barrel racer. The time it takes barrel racers to complete their runs, right? This person did it in 11 seconds, 11 seconds, 12, 12. Oh, and they so nicely already put it in order for us. So, okay, so what is the unit of measurement for the data? So how are they measuring the time? And then how many observations were made? It's just how many barrel racers did they keep track of? And then what strategy or tool would you use to make a dot plot of the data? So, right, we want, these are already in order for us. So we're going to list each number on a number line. So 11, 12, 13, 14, 15, 16. So in a number line. And then every time I see an 11, I put a dot above 11. So it looks like I'll have 2 dots above 11. 1, 2, 3, 4 dots above 12. 1, 2 dots above 13. 2 dots above 14. 3 dots above 15. And 1 above 16. So go ahead and read through, and so select all the correct answers of things you would do to make a dot plot. So this dot plot shows the amount each customer spent during a 1-hour period at a coffee shop. So each dot is a customer. So if you're still wondering about that dot plot on the last question, here's a good example of one. So we just had the numbers 11 through 16 on ours with a dot above those for the barrel racers. So here, every dot is a customer, and I can see these customers spent $2 all the way up to this customer spent $8. So how many customers made a purchase at the coffee shop? So every dot is a customer, so we just need to count up all of those dots. Which of the following is an example of a statistical question? Select all that apply. So remember, we are looking for questions that have lots of answers and ask lots of people or look at lots of different things. So not just a month, not just a book, not just, right, one pot. So lots of kids that we asked, lots of different answers or lots of different things were being observed. Let's go through and find the statistical questions. Okay, and then our last one is just looking at these frequency tables and a histogram. So they took our data and they broke it up from 132 to 138. So I can see 132, 33, 34, 35, 36, 37, 38. So there are 7 pieces of data in this group. So that means from here to here, 132 plus 7 is 139. 138 plus 7 is 145, right? So I want 7 in every group. So we've got a pattern of just adding 7 on to the front and the back. So added 7, added 7, added 7, added 7. So that pattern keeps repeating, 7 in every group. So we can see they said there were 14. So This is their age in months. So, right, like we keep track of babies in months. Say when you have a newborn baby, they're 1 month, 2 months, all the way to get to 12 months. And then we usually just go by ages. So if I wanted to figure out my age, I would take my age and times it by 12. So, right, these people are kind of old. Okay, maybe not that old. So maybe right for you, you are 11. Okay, so yeah, these people really aren't that old. They're probably your age. So you really think I'm old now. I've lost my mind. So, right, you're 11, 12 times by 12. Most of you were about 130-ish months to 145, 6, 7, 8. So you guys are right somewhere probably in this range here. So even though these sound really old, they're actually not super old. It's like these are like 9, 10, 11, 12, 13, 14-year olds here. So they broke them up into equal intervals. So there's 14 of the youngest, then 13, then 8, then 6. So we are looking for the matching one. So one thing to remember is that histograms touch. So I can already see two that cannot possibly be a histogram. I just see bar graphs. So let's see what our hint says here. Oh, yep, just reminding you of the same thing I just told you, no spaces. So then we want to make sure that it goes up to all of the right frequencies to represent our data. Okay, so go ahead and finish up that. And if you have any questions about making a dot plot, a frequency table, or a histogram, then please let me know and we can set up a time to meet together.